Hello everyone, now we'll see some problems on determinant. These problems are important for 4 marks. I mean in the party, not this one. This is for 1 marks. Okay, next we have some more problems. Those are important for 4 marks. Now we'll see this one. Evaluate 102, 18, 36, 134, 73, 6. So you have to find the determinant of this one. So this is, as I told you, this is a 1 mark problem. So directly you have to solve this one, right? No need to expand this one. What we can do here? See here, this is 17, 3 and 6 is there. If I take 6 common here, if I take 6 common here, in the first row, this will be now 17 into 6 is 1 or 2, right? 6 into 17 is 1 or 2, so this will be now 3 and this is 6. So this is now 1, 3, 4 as it is. This is 17, 3 and 6. Now you can see this first row and last row. These are same, right? 17, 17, 3 and 3, 6 and 6. Whenever any two rows are identical, then the determinant will be equal to 0. So directly I can write the determinant of this is equal to 0. Simple, 1 mark problem. Here also, show that ABC, so the next one, show that ABC, A plus 2x, B plus 2y, C plus 2z and xyz. Here you can see this one, here ABC is there, here also ABC is there, right? By using the fifth property, what we can do this one? We can split this, right? A plus 2x is there. So, you can write this one as a 2 determinants. I'll write this one. This is A, B and C. This is now A, B and C. This is x, y, z, right? Sum of the values can be written as a sum of the 2 determinants. Plus, next will be this one. A, B and C. So, this is now 2x, right? 2y and 2z. And this is now x, y, z. Is it clear? So now this is here also first row and the second row is same. So this will be determinant will be equal to 0. Here plus here you can take 2 common. 2 is constant, right? If I take 2 common, what happens here? This is x and this is y and this is z. Here also you can see this one x, y, z. Here this is x, y, z. So this is also equal to 0. So we proved this is equal to 0. I hope you understood this one. Now is the next problem. Problem is given that prove that this determinant is equal to a cube. Now this type of problems are important for 4 mark problems, okay? I mean in the party, you have to show determinant of this is equal to a cube. Directly by the expansion we can't prove this, right? It will be lengthy. For that reason what you have to do is, you have to apply the operations, I mean transformations. You have studied in the matrices. In this total 9 elements are there. In these 9 elements, you have to make at least 2 or 3 elements as 0. Okay, it depends on the problem. Either 2 or 3 elements should be equal to 0. Then only you can expand. Then you can prove that it is equal to a cube. Is it clear? Now what I do is, here 2a is there and here 3a is there. I make 2a as 0. For that, I will consider R2 changes to R2 minus 2R1, right? So that means 2a minus 2a will get cancelled. So this will be 0. And here 3a is there. So what you can do here? R3 changes to R3 minus 3R1. So this will be now 3a minus 3a will be equal to 0. I hope you understood this one. Now what I do? As I told you, I will change R2 changes to make this as 0. R2 making this will be 0 will be difficult, right? So I will go with the 2a and 3. So R2 changes to R2 minus 2 into R1. Is it clear? Now we are changing only R2. So this is now first will be as it is A plus B and this is A plus B plus C. Now 2A minus 2 into A, that will be 2A minus 2A will be equal to 0. This will be now 3A, right, plus 2B. We will have to multiply by 2 and you have to subtract, that is minus 2A and minus 2B. So plus 2b and minus 2b will get cancelled. 3a minus 2a will be equal to a. Next one will be now 4a, right, plus 3b plus 2c. Now you have to multiply by 2 and you have to subtract, that is now minus 2a. I hope you are understanding this one. Minus 2b minus 2c. Plus 2c and minus 2c will get cancelled. 4a minus 2a will be equal to 2a and 3b minus 2b will be equal to plus b. This is row 2 we have changed. Now we will change the row 3. If you want to, do in the next step, you can do that, or else you can do here only without affecting these 2 elements. Is it clear? Now I can write R3 changes to, simultaneously you can do, but you should be careful while doing this one. You are not supposed to affect any of these elements. So R3 changes to R3 minus, here I need 3, right? Minus 3 into R1. So these two elements, these two rows will be same, right? Now we are changing only R3 so that you can give the operation simultaneously, this and this one. I will change this one. 3a minus 3a will be equal to 0. Now this is now, see, 6a plus 3b multiplying by 3, right? So minus 3a and minus 3b. So plus 3b and minus 3b will get cancelled. 6a minus 3a will be equal to 3a. Next one will be C. 10a plus 6b plus 3c minus, so that will be now 3a minus 3b and minus 3c. Here also plus 3c and minus 3c will get cancelled. 10a minus 3a will be 7a and 6b minus 3 will be equal to plus 3b. So this is now last element, 7a plus 3b. So now in this operation we made two elements as 0, right? So these two elements are 0. Now can we apply the, can we expand this one? If we expand this one, what happens? Here this first column is two elements are 0, right? So if you go along this first column, what happens? This one a into, I have did it first row and first column. I have to multiply these two and these two, right? Again it will be lengthy. I have to multiply a into this one and again this into this one. And I have to prove it is equal to a cube. It is not possible, right? In this step, if you expand this one, we can't get the a cube. So we will give the one more operation. So that operation is here. See, here other than this will be difficult, right? See here 3a is there and here a is there. If I change the R3 row as R3 minus 3R2, right? R3 minus 3R2. So 3a minus 3a will be equal to 0. I hope you are getting this one. So now what I do is I will change the R3 row. R3 changes to R3 minus, I will multiply 3, that is 3R2. Is it clear? Now I am changing only R3 row and first rows will be as it is, that is now A, and next will be A plus B, and next will be A plus B plus C, and this is 0, A and 2A plus B. We are changing R3, so 0 minus something, so this will be 0. So this is 3A minus 3A will be 0. So this will be now 7A plus 3B. We are multiplying by 3 minus 3 into 2 will be 6A minus 3B, right? Plus 3B and minus 3B will get cancelled. 7A minus 6A will be equal to A. I hope you understood this one. This is equal to A. Now, can we expand this one? Now again these two are 0, right? If I expand along this one, this first row and first column will get cancelled. So I have to multiply A and A. It will be A square. And this will be 0 into 0. So we got A into, right, A square. It will be equal to A cube. So now we will expand along the, is it clear? Because here first column is 0. Or else you can go with this one also, no problem. Okay, you'll get the same thing. Or else you'll go with this one. So this is now by the expansion I can write A into, if you want to write expanding along which column? First column. Is it clear? Because there in the first column two elements are 0. Now I'll expand along first column. So I'll delete first row and first column. A into A will be A square minus 0 into this one will be minus 0. So A into A square will be equal to A cube. We proved this one. Is it clear? You have to make some elements as 0. Then you have to give the expansion. Next problem. This is a simple problem. Without expanding, prove that this is equal to 0. This is given. Prove that this is equal to 0. Now you have to observe here. Here x plus y is there, right? Here z is there. And here y plus z is there. Here x is there. Z plus x is there. And y is there. So what I can do? I can write, see, R1 changes to R1 plus R2. If you add this, what happens here? This will be now x plus y plus z. This is y plus z plus x. This is z plus x plus y. All the same, right? Then you can take that common. Is it clear? So that we will get the two rows are equal. So it will be equal to 0. We will do that one. So delta is equal to, I told you, R1 plus R2. So we are adding this one. So this is now x plus y plus z. So this is also x plus y plus z. So this is also z plus x plus y. And remaining elements are as it is, z, x and y. So this is 1, 1 and 1. Here you can see this one in the first row, x plus y plus z is common, right? So you take that out, x plus y plus z, what is remaining? 1, 1, 1. So this is z, x and y, and this is 1, 1, 1. Two rows are equal, identical, so this will be equal to 0. So this is determinant of this one equal to 0. Simple. So the next problem is given. Evaluate delta is equal to 1a bc, 1b ca, 1c ab. This is also important one. Okay. Now see here, you can observe here. First column, all the elements are equal to 1. Right? Here all the elements are 1. If it is in this case, what you can do is, the simple thing is just keep the first row as it is. Okay, keep the first row as it is and change R2 by giving the operation. Use R1 to subtract these two. Is it clear? Keep the R1 as it is and change R2, changes to R2 minus R1. Okay, and then R3. You can give simultaneously. R3 changes to, you are not supposed to give R2 because already you changed R2 here. Is it clear? Here already you have given the operation R2, so you can't use here R2. That's why I told you fix the first row R1. So R3 changes to R3 minus R1. I hope you understood this one. Okay? And this is not compulsory, this one only. You can keep R2 as it is. Then what you have to do? R1 changes to R1 minus R2. Again you write R3 changes to R3 minus R2. Okay, or else what you can do, if you don't want to do this one, means you can directly go R1 changes to R1 minus R2. You got one determinant here. Okay, after completing this step, anyway R1 is changed, you can change R2 or you can change R3, whatever. Okay, whatever the method you can use, that is left to you. But if you use this one, it will be easy. Usually I do like this. Okay, what I do, first I will keep the row as it is, then I change R2 by using R2 minus R1. So I use R1 to subtract this. Again similarly R3 changes to R3 minus R1. So if it is like this, 1, 1, 1, here something is there, A, B, C, and here X, Y, Z is there. Now here one row is 1, right? What we can do here, you just keep the column 1 as it is. So change C2. C2 changes to C2 minus C1. Is it clear? Then you change C3. C3 changes to C3 minus C1. Is it clear? Here you use C2 minus C1. So you can't use C3 changes to C3 minus C2. If you use this one, it is wrong. Because already you changed to C2 here. That's why I told you keep the first column as it is. I hope you understood this one. Yes. Now we'll use this operation. So R2 is changing. Now the remaining terms are as it is. So first row is as it is. That is 1A and BC. R2 minus R1. So 1 minus 1 will be equal to 0, right? And then B minus A. So this is now B minus A and this is CA. Is it clear? CA minus BC. Simultaneously we can do another operation. R3 changes to R3 minus R1. So that is 1 minus 1 will be equal to 0. So C minus A. So this is C minus A and here this is AB minus BC. Is it clear? So this is now we have to expand this one. Sorry. Before expanding this one, here you can see this one. Here B minus E is there. Here C is common, right? If I take C common, what is remaining here? A minus B. Is it clear? So for that reason I will take common there. So first term is as it is 1. First row is as it is 1A and BC. So I will write 0. So this is now B minus A. I will take here C common and this is now A minus B. Next one here, this is 0. Now we will take C minus A and here which one is common? B is common. We can take out, if we take out B is common, this will be now, right? A minus C. Is it clear? Then now next step. First one as it is, that is 1, sorry, this is 1 A and 1A and BC. First row is as it is 1A and BC. Here 0 B minus C is the C into A minus B is the. I can take A minus B common, right? This will be minus 1. Is it clear? I have taken, if I take A minus B common, so I will take A minus B common. If I take A minus B common, Here this is anyway 0. Here b minus c is the b minus c we can write minus of a minus b. Is it clear? Minus of a minus b. So this is now minus 1 is remaining. Here c is remaining in the second row. Here c minus a is there and here a minus c is there. We'll take a minus c common. Anyway, either a minus c or you can take c minus c. If I take a minus c common, here remaining with 0 and this is now minus 1. Next one here a minus c is there, so remaining with b. I hope you understood this one. Now here a minus b and a minus c is there. Two elements are there, 0, right? Here either you can expand here only. If you expand here, you will get a simple term, right? So this is minus 1 into b, that is minus b, minus 1 into minus c. Is it clear? Directly you can expand this one, or else if you want, you can do the another operation, that is r3 changes to, you can subtract these two, right? So r3 minus r2. So minus 1, this will be plus 1. So this will be now 0. Then you can give the, then you can expand. Or else here only will expand. Anyway, so this is now a minus b into a minus c. Then here you can see this one. First column is there. Two elements are 0. So I'll go with this column. So 1 into, I'll delete the first row and first column. So this is minus 1 into b will be minus b. Minus is there, right? Into minus 1 into c is minus c. So this is equal to now a minus b into a minus c into this is minus b and plus c, right? So this one I can write a minus b into c minus b into a minus. This is the answer. I hope you understood this one, important one. Okay. Take down this, everything you have to write down. Now is the next problem. It is given that prove that determinant of b plus c, a, this b, c plus a, b, c and a plus b is equal to 4ac. This is one of the important problem. Don't expect more than one question from this concept. Only one will be there, but this is also a repeated question. Okay. Now, as I told you, you have to make 2 or 3 elements as 0, right? The simple thing is what you can do. You can subtract these two, right? c2 minus c3, or you can go with c1 minus c2. Or you can go with, right, c1 minus c3. But if you apply that operation, the problem will be very lengthy and you can't get this one is equal to 4abc. For that reason, here you have to apply the operation as r1 changes to r1 minus r2 minus r3. This operation you have to give. Sometimes you have to remember the operations, otherwise it will be difficult in the exam. Okay, but don't buy at this one. By practice only it will come. Only few problems are there. If you practice those problems now, while looking this problem, yes, you come to know that yes, I have to apply this operation. Okay, now we will change the first row. I hope you understood this one. So the second and third is same. I'll write this one b, c plus a and b. This is now c and a plus b. This is now b plus c minus b and minus c, right? b plus c minus b and minus c. Both will get cancelled, so this will be equal to 0. Next, this is c, a minus c minus a minus c. So here plus a and minus a will get cancelled. Minus c and minus c will be equal to minus 2c. Third one will be a minus b, right? Minus a and again minus b. So which one will get cancelled? Plus a and minus c, minus b and minus 2 will be equal to minus 2. Right? So this is now directly we expand this one. If you expand this one, you will get that answer. So, right? So this is now, I'll expand along the first row. So this is now 0 into first row and this will be something will be there. So it will be equal to 0. Right? No need to write this one. This will be equal to 0. So now this is, you know that this is plus and this is minus and this is plus. So minus into plus will be, this is plus 2c into, delete first row and first column, multiply this. So now this is b into a plus b, right, minus c into b. I hope you are getting this one. Next term will be minus 2b. Now delete first row and last column. So this is b into c minus of c plus a into c, right? c plus a into c. We'll expand this one. So this is 0 plus 2c into multiply ab plus b square minus cb, right? This is now minus 2b into BC minus C square and minus AC. Just we have multiplied there. So this is again we'll multiply this one. So this will be now 2CAB. What do we have to prove? 4ABC. We got 2CAB, right? Next plus 2CB square minus this will be now 2 into C into C will be C square B minus, so this is again 2B square into C and minus into minus will be plus 2B into C square minus into minus will be plus 2BAC. Now obviously something will get cancelled, right? 2CB square, 2CB square, right? Plus 2C square B minus 2C square B and C square B. Now remaining with 2CAB and 2ABC, right? Both are same. So this is equal to 4ABC. Proof? Is it clear? If it is this one, what operation you have to give? Just you have to subtract all the rows. R1 changes to R1 minus R2 minus R3. Remember this one. Okay? Yeah. Next problem. If x, y, z are different, all the three values are different and determinant is equal to 0 is given. This is given and you have to prove that 1 plus x, y, z is equal to 0. Right? See here, it is given that sum of the two terms are there, right? So you can express this one as a sum of the two determinants, right? We'll write that one. First, I'll write this one as a sum of two determinants. First x square and this is 1, y square and 1. So this is z square and 1, right? Plus, so this one can be written as now x square and last term is x cube. Next will be y square and y cube, that will be z square and z cube. I hope you understood this one. Here some of the two terms are there by using the property phi. Now first determinant I will write as it is x square and 1, y square and 1 and this is z square and 1. Here you can see this. In the first row x is common, in the second row y is common and in the third row z is common, right? We'll take out directly I will write x, y, z. I mean x is from the first row, y is from the second row and z is from the third row. It is not total one, right? So we have taken x common, so this will be now 1 x and this is x square. So this is now 1 y and y square and this is now z, this is now 1, right? And this is z and this is z square. Now we can compare these two. X square 1 is there, 1x square is there, right? Both are similar but the rows are different, right? For that reason we will interchange these rows. Is it clear? To make these two determinants same. So if I interchange these two, what happens? If you interchange any two rows or columns, then determinant will be multiplied by the negative sign, right? Now I will interchange these two rows. Is it clear? So I will write, I hope you are getting this one, 1 here and x square, y square, z square here. Now the determinant is multiplied by minus 1, right? Again, but I need this one. Here 1 is there. I will interchange these two. So that this is now 1 will be here and x, y, z will be here. So we interchange the rows two times. So that is minus 1 into minus 1. Minus 1 whole square. Is it clear? So this is now, see, what I do is, now x, y, z is as it is. I write 1 and that is x square, y square and z square. So interchange, so it is multiplied by minus 1. Right? So this is multiplied. Again I will interchange these two. That is 1. So this will be now x, y, z. So this is as it is. X square, y square, z square. So again I will multiply by minus 1. Right? So minus 1 is multiplied 2 times. Here I will do directly. I hope you understood this one. So this is multiplied by minus 1 square. I interchange this one. So this is now 1. Same both are x, y and z. So this will be now x square, y square and z square plus x, y, z and this is 1 and this will be x square, y square, z and z square. Now you can take this determinant common. It is same in the board. I don't have place here, so I will erase this one. By taking this determinant, directly I have written, I have taken 1 x square, 1 y square and 1 z square common. here remaining with first determinant is 1 and in the second determinant is remaining x, y, z. So 1 plus x, y, z is remaining, right? Already we got the answer, right? So this is we got. Now we have to prove this is equal to 0. But we have one determinant here, right here as I told you, column 1 is 1, 1, 1 is there. So we'll make expand this determinant, we'll make these two elements as 0. So what we'll do, we'll change R2 changes to R2 minus R1 similar to the previous problem, and this is R3 changes to R3 minus R1. Now we'll do this one. So row 1 is as it is 1 x and x square, 1 minus 1 0, y minus x, right? Y minus x, so this will be now y square minus x square. After this is 1 minus 1 will be 0, z minus x, I hope you are getting. So this is z square minus x square, z square minus x square into remaining 1 plus x, y, z. Is it clear? So this is equal to first row as it is, that is 1x and x square. Here you can see this 0, y minus x, y square minus x square. So I can write this one as y plus x into y minus x, right? So that we can take y minus x common. Is it clear? If you take y minus x is common, what is remaining here? 0, this is 1 and here remaining with y plus x. And here z minus x is there. So this is now z square minus x square. You can write z plus x into z minus x. So that you can take z minus x common. If I take z minus x common, remaining here 0 and this is 1 and this is now z plus x. Understood? Z plus x. Now, so this is as it is, the product is there. I'll write this one as 1 plus x, y, z. I have written first this one. Then here we have taken y minus x into z minus x, right? And determinant of this one is this. Directly we will expand this one. Two elements are 0 here. I will expand along this column because 2 are 0 here. If I expand this one, so first row and first column will get cancelled. So this will be 1 into z plus x, right? 1 into z plus x. So this will be multiplied. So that is minus y and minus x. So this is given that the determinant here also you have to take, you have to take 0. It is given that this is equal to 0. So here which one? Plus x and minus x will get cancelled. What is remaining? 1 plus x y z, y minus x into z minus x into z minus y is equal to 0 will get, right? Product of these terms is equal to 0. I mean 1 should be equal to 0, right? That means either y minus x is equal to 0 or this is equal to 0 or this one or this one. If it is y minus x is equal to 0, what happens here? Y is equal to x. But it is given that x, y, z are different. So y minus x can't be equal to 0. If it is z minus x is equal to 0, again z equal to x. Not possible. Here if it is z minus y is equal to 0, then again z is equal to y. This is also not possible. So y minus x is equal to 0 and z minus x is equal to 0 and z minus y is equal to 0 is not possible, right? Why it is not possible? Since x, y, z are different, right? X, y, z are different. So this is, by this we can say that 1 plus x, y, z is equal to 0. Proved. I hope you understood this one. This is also one of the important problem. Show that 1 plus a, 1, 1, 1, 1 plus b and this is equal to c. You have to observe this one. This one determinant you have to prove as 1 plus 1 by a plus 1 by b plus 1 by c. So we need to get this value, right? You have to prove this one. For that reason, what you have to do is, you have to remember this one. You have to take a from the first row. You have to take a as common from the first row and b from the second row and c from the third row. You have to remember this one. Take a from first row, okay, R1 and b from R2 common, okay, c from R3. This is the first row. You have to take a from the first row. So if I take a from the first row, what happens here? This is, I have taken a common. So this will be now 1 by a plus 1, right? So this is now again 1 by A and this is also 1 by A. The reason you have to get this value, right? And if you take B from this one, this will be now 1 by B and this is now 1 by B plus 1. So this will be now 1 by B. Okay, so we have taken B common, A is there, B. Then the last row will take C common. So if you take C common, this is remaining with 1 by C. So this is also 1 by C and this is 1 by C plus 1. It's clear? Now, next step what you have to do is ABC is there. See here, you need 1 plus A, this one, right? So if you add everything, you will get 1 by A plus 1, 1 by B plus 1 by C, right? So we can change R1 to R1 plus R2 plus R3. Is it clear? If you add these things, you will get that term. So we'll add this one. R1 changes, that is 1 by A plus 1 plus 1 by B plus 1 by C. Now here if you add this, this will be now 1 by A plus 1 by B plus 1. So this is also 1 by A plus 1 by B plus 1 by C plus 1. So clear? Now remaining terms as it is 1 by B and this is now 1 by B plus 1 and this is 1 by B. Last row is as it is, that is 1 by C, this is also 1 by C and this is also 1 by C plus 1. I hope you understood this one. I don't have place, I will erase this one. See here, already ABC is there, right? I have taken, plus 1 is there, right? In the first row, this was there, 1 by A plus 1 by B plus 1 by C plus 1. From the first row, I have taken out remaining with here 1, 1, 1 and remaining 2 rows are same. I hope you understood this one. Now, see, first just you have to remember the first operations. Later on, it will be easy. So, here 1, 1, 1 is there, right? What you can do? It is along the, this is in the row 1, 1 is there. So, you can give the operation along the column. What I can do? C2 changes to, right? C2 minus C1. Keep column 1 as it is. And one more, C3 changes to, what we have to give? C3 minus C1. Is it clear? Now, I'll write this one. So, first column is as it is 1. Before that, this is there A, B, C and this is 1 by A plus 1 by B plus 1 by C plus 1 into column 1 is as it is, that is 1, 1 by B and 1 by C. So, this is C2 minus C1. 1 minus 1 will be 0. 1 by B plus 1 minus 1 by B. So, 1 by B and 1 by, I hope you understood this one. Understood this one, 1. So, 1 by C minus 1 by C will be 0. So, this is now C3 minus C1. So, 1 minus 1 will be 0. So, 1 by B minus 1 by B will be 0. 1 by C plus 1 minus 1 by C. So, 1 by C and 1 by C will get cancelled. So, this will be equal to 1. Now, many zeros are there, right? Directly we will expand this one. Is it clear? Already we got the answer, right? So, we have this one, ABC into this one. So, this should be equal to, if it is 1, then we got that, right? So, this is equal to, I will write this as it is, ABC into 1 by A plus 1 by B plus 1 by C plus 1. Now, we'll expand along the first row because here 2 zeros are there. So, delete this one, 1 into, right? So, delete first row and first column, 1 into 1. This will be now 1 minus 0. Is it clear? So, we proved this is equal to ABC into 1 by A plus 1 by B plus 1 by C plus 1. This is the proof. I hope you understood this one. These all are example problems. Now some more exercise problems are there. We will solve that one in the next session. Okay? Practice this.